This is lesson 12.1, day 2. So there are special triangles that we talk about often in trig. So one is a 30, 60, 90 triangle, and another one is a 45, 45, 90. So the 45, 45, 90 triangle is an isosceles triangle, which means the legs are both equal, and the hypotenuse has the ratio of x times the square root of 2. And then you can see up there on the 30, 60, 90, the leg that's opposite of the 30-degree angle is the shortest leg, that's x. The one that's opposite of 60 is x root 3, and the hypotenuse is always twice the length of the long leg, or the short leg. So these are some ratios that I'll reference as we do our calculations today. All right, so we're going to be using trig functions to find missing side lengths in this lesson. So the first thing that's very important is to change your calculator to make sure it's in degree mode, which means if I have my calculator up here, clear the memory. You want to click the button that's right next to the second blue button, which says mode. After you click mode, you're going to see it blinking on normal. We want to go down to where it says radian and arrow once to the right, so it's on degree, and it should be flashing on degree. You press enter, and it should now have the black background around degree. And up at the top, you'll see it says normal, float, auto, real, degree, and then MP. So if that's the case, then you can go second quit. So your calculator is now in degree mode. If you don't have your physical calculator with you from school, there were calculator apps that were downloaded on the Chromebook, should be down at the bottom there. But if you have trouble, send me an email and I'll try to find another online resource for you. So using trig functions to find the missing side length. So we had a triangle here that had a measure of 30 degrees. So I highlighted that. And then next you want to label the opposite side, the adjacent side, and the hypotenuse. So notice that I crossed off the opposite side because it wasn't labeled. We don't need it. So the only two sides we're going to focus on this problem are the adjacent side, which is x, and the hypotenuse is 8. So we're going to be using the degree, the x, and the 8 for this question. So since the sides I do know something about are the adjacent and the hypotenuse, you should know that that's a over h, which is the cosine function. So to set up your ratio, you have the cosine of 30 degrees equals the adjacent over the hypotenuse sides, or x over 8. Now, in the previous slide I showed you, cosine of 30 is one of our special functions, and it is equal to the square root of 3 over 2. So I can replace the square root of 3 over 2 where cosine of 30 degrees was, and then use cross products or cross multiplication to figure this out. So 8 times the square root of 3 is equal to 2x. If you divide each side by 2, you get 4 root 3 equals x. And if you type that into your calculator, 4 times the square root of 3, and get a decimal, it wants us to round to the nearest tenth, which is 6.9. I do want to share that there is another way to do this. If you want to get rid of the denominator on x divided by 8, you would multiply both sides by 8. So you could go to your calculator and type in 8 cosine of 30 and press enter, and you'll get this decimal, which is the same answer rounded to the 10th, 6.9. All right, 3a. So on this one, I highlighted my degree that they gave us, 60 degrees. I labeled the opposite side, the hypotenuse, and the adjacent. On this one, again, I don't need the opposite side because nothing was given, so I'm going to use the adjacent and the hypotenuse again, which is cosine. So set up your ratio. Cosine of 60 degrees equals x over 14, the adjacent over the hypotenuse. And you can use the fact that cosine of 60 degrees is a half, so you can replace that with that section. And a half is equal to x over 14. Use cross products and divide by 2, you get x is 7. Also on this one, another way of solving it is, since you're dividing x by 14, you could do the opposite, which is to multiply both sides by 14. So you would type in 14 times the cosine of x, or in this case 60, and you get 7. On 3b, I highlighted the angle that was given, 45, labeled its opposite, adjacent, and hypotenuse sides. This time, the adjacent side didn't give us any information, so now we're going to use opposite and hypotenuse, which is the SO part of SOHCAHTOA. So we're going to be using sine here. So sine of 45 degrees equals the opposite side of 10 over the hypotenuse of x. One way you could solve is the sine of 45 degrees is a special angle, so that gives you the square root of 2 over 2. And then you can use cross products and solve that one. You get 14.1. All right, so the calculator is going to come in handy for the angles that aren't 30, 60, 90 or 45, 45, 90. So if we had odd angles like this one has a 76 degree angle, we're going to definitely use our calculator to help us with this one. So this is a real life scenario. You have the height of the building. Joel walked 200 feet from the base of the building. So that's you see in the picture. He's using an inclinometer to measure the angle of his eye to the top of the building. So his eye level is at 6 feet. How tall is the building? So we know Joel is 6 feet tall. He uses a tool that measures to the top of the building, which creates a right triangle with the angle at 76 degrees. So now you want to highlight or identify your 76, label the three sides, opposite, adjacent, and hypotenuse. The hypotenuse doesn't give us any information here, so I'm going to cross that one away and know that I have to use opposite and adjacent, which is tangent, TOA. So I have tangent of 76 degrees equals the opposite side, D, divided by the adjacent side, 200. And you could do what I showed you before. If we're dividing D by 200, we want to multiply by 200 to get D alone. So 200 times tangent of 76. If you type that into your calculator, 200 times tangent of 76, you get this decimal. We're going to round it to the nearest whole here, so that's 802. And since he was 6 feet tall, we have to take that into account that he was holding this measure at eye level. So we need to add 6 feet on this one. So the height of the building is 808 feet. All right, here's some practice problems before you get to the homework. So the homework will count as credit points for your homework grade. But pause the video and practice these problems on scratch paper, rounding to the nearest tenth. And then unpause for the answers. All right, here are the answers. So on this case, 60 degrees, the sides I know are opposite and hypotenuse. So you wanted to use sine on this one. Number 10, the sides that you know are the adjacent and the hypotenuse. So you want to use cosine. And on the number 11, the sides you know are the opposite and the adjacent. So you want to use tangent on that one. This is another example that might come up in the quizzes homework that you're going to be doing. On this one, we knew the opposite and the adjacent side, and this time our x was in the denominator. So you have to solve these ones a little bit differently. If I want to undo everything to get x by itself, if 8 is being divided by x, then you can multiply both sides by x. So that's how you see x tangent of 30 equals 8. And then you can divide both sides by tangent of 30. So you can go directly to your calculator, make the fraction. So go alpha y equals, put the 8 in the numerator, and tangent of 30 down in the denominator, and press enter, and you'll get about 13.9 rounded to the nearest tenth. So that's how you can solve those types of questions when your variable's at the bottom. All right, so your homework is to complete 12 quizzes problems on finding missing side lengths in a right triangle using the trig ratios. So you will definitely need a calculator to do these questions, and most likely a scratch piece of paper to work out the problems first before you answer. Again, make sure your calculator is in degree mode, otherwise you'll get all the answers incorrect. There you go. If you have any questions, send me an email.